So determine whether the triangles are similar. If they are similar, write a similarity statement and then find the scale factor. So we want to start by listing our congruent angles. So we have one arc on, it's B to A, so that means B is going to be on top, A is going to be on bottom. So we'll do angle G is congruent to angle B because they both have one arc. Then we'll go to the right angle. Angle F is congruent to angle D, thank you. And then the last one was E. And which one was it congruent to? Thank you. C. And we matched up those congruent marks. Then to see if these are similar, we got to write out those ratios to see if they're the same. And then we can tell if that's the scale factor. So let's start with one arc to right arc. So GF. One arc to right angle, So that's going to be BD. And we're going to pick up there and go around. So that means FE. And the other one's going to be DC. And then we have EG and CB. So I'm comparing the sides. I just looked at the number of arcs we had to compare it with. And then to see if these are similar, we actually got to fill in the information. How long is GF? 48. And how much is DB or BD? 24. What is FE? And CD? And then EG. And then the other one? Thank you, Natalie. So when we look at this, now we're going to see what we have in common. What's in common between 48 and 24? 24. 24 goes into 24 one time. 24 goes into 48 two times. And we have 14 and 7. So what goes into both 14 and 7?
7.
How many times does it go into 14?
2.
What's common 50 and 25?
25.
Yep, and it goes 1 and 2. So we end up with a ratio of 2 over 1, which means my scale factor is 2 over 1. And then the last part of this says, make a similarity statement. And so when we do that, we can just use this portion over here, and we can write it out as is. So triangle GFE is similar to triangle BDC. And we just wrote those down just like we did on the other one so that the congruent angles line up next to each other. On the next group, it tells you that these are two similar shapes. What do we know about shapes that are similar about the angles? The angles are congruent. So we can go through here and we can fill out what we know. We know this is going to be a right angle. We know this is going to be a right angle. We know this is going to be 138. And we know this is going to be 42. And we know that because it already tells us that they're similar. So what is going to be the value of angle T? Well, we see angle T is congruent to angle L, so that means the measure of angle T has to be how much? 138. And then angle V is congruent to angle N, which means it has to have a value of 90. And then the last portion here says find the value of X and then find the value of Y. So we can list these out using the letters of the sides. Are you guys okay if I just fill in the information as is, the side lengths instead of being KN over SV, or do you want me to do that too? I didn't hear what you said.
Which one's easier? Yeah.
Okay. So they're both the same thing. One's just one more step. We'll do it this way on this example, and the next one I won't. So we'll just do KN over SV equals NM over VU, which equals ML over UT. We can continue going, but that top side doesn't have any information for us, so I'm not going to write it out. And then we're going to substitute in what we know. KN is 6, SV is 8, NM is Y, VU is 16, ML is 9, UT is X. So our first one says find X. So for number 4, we're going to use the equation or the ratio that we know, 6 over 8. And we're set equal to the one that has X in it right here, 9 over X. And then we're back at that cross multiply and solve problem. So we have 6X equals, what's 9 times 8? 72. Divide by 6. X equals 12. Thank you, guys. And then our next one up, we're going to do the same idea, but now we're going to use the one that has the y in it. And then the ratio that we already know. You could, again, use the 9 over the 12 that we just created, but it's always best to use what was already known in the problem. So I'm going to do number 5 right underneath it. So 5 is going to be 6 over 8 equals y over 16. Or cross multiply. 8y equals 6 times 16. 96. Okay. Okay, divide by 8. We end up with y equals 12. 7.3 AA postulate. So your objective today is to show that triangles are congruent using AA similarity postulate. So here we have the AA postulate. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So before this, to show that triangles were similar, you had to show all of the angles were congruent and all the sides had the same ratio, the same scale factor. But here, this is telling you that if you know that two angles are congruent, what do we know about that third angle? It has to be the same, right? Because you know two angles, whatever the other one is, it all has to add up to that same 180. It has to be the same. So now we don't have to do this. This is like a shortcut method. We can just use AA and we'll know. Okay, and then we'll go on to the next one. So example 1, must the triangles be similar? And if so, write a similarity statement. So we're going to look at these and we're going to see if we know anything. We see that we have a 63-degree angle and an 80-degree angle. And over here we have an 80-degree angle and a 27-degree angle. Do we have any of those that match? Yep, the 80. So we have angle B is congruent to angle E. And we have two angles that don't match, so we can choose which angle we want to solve for. Either one of them will let us know. Do we want to solve for C or for B?
B.
For B? I mean D, sorry. D?
Oh, yeah.
Okay, so 180 minus 27 minus 80. What do we get? Okay, so we have 73 there. We don't have to solve for this one because we know it's not going to be 73, right? It's not going to end up being that 27 since that didn't add up that way. So no, these are not similar. Here we want to see if these triangles are similar, and if they are, we're going to write the similarity statement. So you see you have the top angle here of 36. You have one of the base angles of 72. We want to look at this and then see if we can find any of the other angles. What do we know about angles opposite of congruent sides? Angles opposite of congruent sides are? Yep, they're going to be congruent, right? So same idea over here. This has to be a 72 because angles opposite of congruent sides are congruent. So to find S and T, we're going to take 180. You're going to subtract the angle you know. So 180 minus 36 should give you 144. And that's going to be split between two of the base angles. How do we split something between two base angles? How do I split 144?
Divide
By
2.
Yep, we get 72. So we know the two base angles are 72. So now I can say angle S is congruent to angle N. And angle T is congruent to angle P. And that's as far as I have to go because by AA triangle, let's do STR, is similar to triangle NPM. So our similarity statement there is writing out the triangles. Make sure you matched up the angles that were congruent. And we can say that they're similar based on the fact that we know two angles are congruent, which is that AA similarity postulate. Okay, so here you see, we want to see if these two triangles are similar. We know something about the relationship between two parallel lines cut by a transversal. So what do we know about these two angles? They're congruent because they are what? Corresponding, yep. So we know that those are corresponding angles, and corresponding angles are congruent when the lines are parallel. So therefore, this has to be 27 as well. So we know that angle E is congruent to angle C. But then we want to look at it and say, do we know anything else about any of the other angles? So we know that D and H are going to end up being congruent because the same idea. And we can actually include that. You said D and, is that a B or, I can't tell. H? We can write H, if that's what you think it looks like. And with the same idea, core angles congruent. And then, since you know that you have two sets of angles that are congruent, we can list them out. Triangle AED is similar to triangle ACH based on AA. When I did this in my last class, I used the fact that A is congruent to A because it's in both triangles. So A is congruent to A because this angle is in the small triangle and it's in the large triangle. But if you're going to use this one down here, I just called that H a couple minutes ago, that's fine too. So example 4. Our first part is finding the angles, and we want to see what the measure of angle ACB. Remember when we do this, the vertex is what's in the middle. So ACB would be this angle down here. So what's the measure of ACB? It's 41. How did you know that, Taylor? Yep, 41 because it's vertical angles. And then after that, we have to find either angle B or angle E or both. So let's start by finding angle B. So to find angle B, we have 180, and we subtract the two angles we have, minus 41, minus 56. Minus 56. And what do you get there? $83. So we see here that we ended up with two angles that are congruent. So we have angle B is going to be congruent to angle D. So we know it's 83 degrees. Now we have two congruent angles in there. So that means angle E has to match angle A. You could do the math, but we know it's going to be 56. So if we're looking at this, angle B is going to be 83 degrees. And angle E is going to be 56 degrees. Now we're moving on to writing the similarity statement for the triangles. When we write this out, we want to make sure that the angles that are congruent are lined up. So I'll start with C, and I'll go to A. B is similar to, so C was the 41, so C, A, so that's going to be E, D, C, E, D. Now we want to find the value of C, D. So I'm looking for this one right here, this length. I'm going to put a little X there. Can you see that? Okay, so when I'm looking for that one, that is between the 41 and 83. The one between the 41 and 83 on the other side is the 10. And then we want to compare it to the one that we know all of the information about. Well, the only other side that we know all the information about is the ends of the bow tie. So that's this 12 and the 8. So 12 is in the same triangle as the X, so it goes on top. The 8 is in the same triangle as the 10, so it goes on bottom. We're going to do a nice cross multiply. 8 times X is 8X. 10 times 12 is 120. We're going to divide by 8. X equals 15. Thank you. So it tells you, or will ask you to find if they're similar. So we want to see what the angles are here. Well, in the first one, we know that we have two 45-degree angles. And the second one, you know you have a 90-degree angle. So to find R and T, we're going to take 180. You're going to subtract the 90 degrees that we know. What's 180 minus 90? 90. And we're splitting it between two angles, so we're going to divide it by 2, which gives us 45 degrees. Okay, so we have 45 degrees. Now I can say that angle X is congruent to angle R, and angle Y is congruent to angle T. So by AA, we know that our two triangles are similar. We don't have to do all the work of matching them up if we don't want to, because it's already written at the top. So angle or triangle XYZ is similar to triangle RTS. And then if that's true, we're going to write all the other similarity proportions. So we're going to start by listing the other angle that we didn't do. So I think that's going to be Z is congruent to angle S is the only one we didn't list. And then we're going to compare the sides. So we have XZ. Oh, nope, XY we'll start with is similar to RXY, similar to RT, which is equal to Z. Oh, I made a mistake, guys. I'm sorry. It should be XZ was the first and the last, so it should have been RS. And then I'm going to compare it to the first two, XY, RT. And then the last two is my last part. So YZ over TS. So you can use the similarity statement like I did, or you can look at the picture to match those sides up.